In the vast cosmic tapestry, there exist objects of unimaginable power. Behemoths that warp the very fabric of space and time. They are an unescapable void where gravity reigns supreme and nothing, not even light itself, can escape. They are called black holes. For decades, these cosmic titans have captivated scientists and dreamers alike. Yet, out of all the theories of them, one truly encapsulates the imagination and creativity of the human mind, the ability to be able to harness energy from a black. Before we dive into the ability to harness energy from them, let's first discuss what they are. A black hole is a region in space-time where gravity is so intense that nothing, not even light, can escape. It acts just like an enormous, high-powered vacuum cleaner that can engulf entire houses, cities, and oceans. The event horizon is the boundary surrounding a black hole, marking the point of no return. Once anything crosses this line, it's pulled into an inescapable prison.
But it seems to be that the world is running out of ideas and resources to come up with energy. So if there is a source of energy that's very high potentially, we should try and utilize it. Also, the gravitational pull is so high that it's difficult to obtain data and analyze it and then work towards making sure that the objective is met of producing energy and then somehow transferring that energy into a useful nature.
What I know of is that black holes have almost infinite gravity and this end up just absorbing everything into them, even light. So just getting something out of them, because they're like just taking everything inside them. So getting something out of them would be a huge challenge, right? I mean, like it will certainly require, if this happens, to be an operational procedure, and if it becomes a successful experiment, I'm sure there's so many scientific challenges.
Now, imagine a black hole that's spinning at incredible speeds. This spinning black hole has a special zone around it called the ergosphere, sort of like a strong wind that drags everything along with it. It's like spiraling down a deadly drain. Now picture this. You send a tiny energy packet into the ergosphere. As it gets caught in it, this energy packet breaks into two smaller pieces. One of these pieces falls into the black hole that takes some of the black hole's energy with it. It's like a tiny thief that takes some energy and disappears into it. Because the black hole lost some of its energy to that first piece, the other piece is ejected from the ergosphere, escaping with more energy than the first piece. This is what we call the Penrose process. Now, let's look at another phenomenon. Instead of a cosmic thief, imagine the vacuum of space is not truly empty, but a bustling sea of virtual particles. Now imagine a sea of virtual particles constantly popping into existence in pairs, one with positive energy and the other with negative energy. If one of these virtual pairs appears right at the edge of a black hole's event horizon, one particle falls into the black hole while its partner escapes. The energy of the particle that escapes comes from the black hole's mass, effectively shrinking it over time. This stream of escaping particles, which we see as thermal radiation, is what we call Hawking radiation. Now, moving on to the final method called Dyson ring, is a hypothetical megastructure designed to harness energy from a black hole. It wouldn't capture energy from the black hole itself, but from its accretion disk, a super hot, bright disk of gas and dust spinning around the black hole. The ring would surround this disk and collect an immense amount of light and heat, turning a black hole's incredible power into usable energy for an advanced civilization.
And I think it will be very much helpful for our next generation or few generations ahead if we work on these tasks diligently and make sure that once we hand it off to the next generation, it's very much progressed, and they can take it to next level, so we can get closer to our objective of harnessing energy from a black hole.
Of course, I mean, like if people have access to, energy at a very nominal and fair rate, it will help improve everyone's standard of living.
We can understand that black holes aren't just an unescapable void, but a beacon for a new era of cosmic civilization. The quest to understand them is far from over, but one thing is clear. The energy of a black hole, once a distant fantasy, might one day be within our grasp.